Hello again, my fellow pilots and my fellow aircraft maintenance personnel. Your host is always Haysam Ali, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today we are going to continue with part 3 from the article related to a great advice to my fellow pilots and my fellow aircraft maintenance personnel. Don't wait to apply the engine fire procedure. Don't wait to apply the engine fire procedure after you receive an engine fire ECAM alert, red ECAM alert. Okay, everybody? In part 1 and part 2, we already discussed the problem and see the past incidents that the pilot delays the procedure for engine fire and the situation become more worse. Okay, everybody? And in part 2, we discuss the difference between engine and the tailpipe fire. So don't wait to look and to see the part 1 and part 2 regarding this article. So let's now start part number 3, everybody. Okay. So in the engine fire procedure, you need to rely on the engine fire alert. You will receive alert in the cockpit. Engine fire indication will have like 6 indication in the cockpit for engine fire. And on each engine you have a dual loop to detect fire. So as you can see here, everybody, this is the engine, okay? And regarding the pylon area, regarding the core area, and regarding the fan area or accessory gearbox, we have the double loop or dual detector loops, loop A and loop B, that detect a fire indication in the cockpit. The loops indicate to the fire detection unit a fire indication or an overheat indication, and the fire detection unit manages the alert through the flight warning computer and indicate in the cockpit for such engine fire like 6 indication. The red fire push button illuminate, fire indication underneath the master lever of the affected engine, master warning, CRC, engine fire indication and engine fire procedure come up on the upper ECAM, and the nacelle temperature come on the lower ECAM, indicating a high temperature in the nacelle. This engine fire also may called a nacelle fire, as the fire propagate between the engine cowl and the engine case, everybody. Okay, so if you have an engine fire indication in the cockpit, this previous mentioned indication, you need to apply the engine fire procedure as fast as you can and immediately. Don't delay the engine fire procedure. Again, don't delay the engine fire procedure. Even if you have a stable parameter of the engine, this is not an indication that there is no fire. If you have a fire indication, thanks to the dual loop, loop A and loop B, and the fire indication depend on double loop detection, or loop A fire, loop B faulty, or loop B fire, loop A faulty at the same time, or loop A and loop B faulty at the same time. Okay, everybody? Okay, so as you can see here, everybody, you need to rely on the engine fire alert. And for each engine, we have detection system for engine fire composed of dual sensing element loops, loop A and loop B. And the engine fire indication come up on a dual loop indication, These loops, everybody, are located in the area around the engine with the highest fire risk. What is the name of this area, everybody? Sensitive area of the engine. Each manufacturer decide what sensitive area the engine have. And probably it will be the high pressure compressor area and the combustion chamber area. Also the accessory gearbox area. Also the pylon. Okay, everybody? This called sensitive area. Why it's called sensitive area, everybody? Because it has flammable fluid duct running in that area and high temperature exists in that area. So if we suffer from any flammable fluid leak in that area, The flammable fluid may be auto-ignite. Oil may be auto-ignite. Fuel may be auto-ignite. And the hydraulic may be auto-ignite in that sensitive area. So that the manufacturer locate its detector loops in that sensitive area. So dual sensing element loops, they are located in the area around the engine with the highest fire risk of fire and the near compartment air exhaust for overheat detection. These are zones where flammable liquid are present. Sensitive area is the area that do have flammable fluids, flammable liquid like oil, fuel, and hydraulic, and also has a high temperature exist in that area. So this zone or these are zones, sensitive area, where flammable liquid are present with a potential ignition source, such as high temperature, such as the accessory gearbox area, the pylon area above the combustion chamber area, and the fan area on certain engine. So here, from this schematic, the sensitive area are the core area, combustion chamber and high pressure compressor, pylon and the accessory gearbox. Okay, maybe the turbine is not mentioned as sensitive area of the engine, so the turbine area don't have a fire detection loops exist, because the turbine, yes, we may have a high temperature exist in that area, but there is no flammable fluid duct running in that area. Everybody. Okay, everybody. So as you can see here again, such sensitive area are accessory gearbox area, the pylon area above the combustion chamber area, and the fan area on certain engine. Each loop is doubled, loop A and loop B, so we have double detection loops. And the fire indication will depend on a double loop detection and gate for redundancy purpose. The loops can detect fire or hot air leaks. Fire detection loops can detect fire or hot air leaks. So, the dual sensing element loops are monitored by a fire detection unit. As you can see here, loop A and loop B feed back the fire detection unit. And the fire detection unit manages the engine fire indication. On the engine fire panel, like the fire push button illuminate in red, fire indication on the engine master panel, fire indication underneath the master lever of the affected engine, master warning, engine fire procedure on the upper E-cam, and land as soon as possible indication. Engine fire procedure, everybody, call for isolation, then fire extinguish. Thrust lever idle, ventilation isolation, air isolation. Engine master lever off, fuel isolation. Engine fire push button push and release, hydraulic isolation, fatigue isolation, IDJ de-energize, pneumatic isolation, air conditioning isolation, and also releasing the fire push button. Okay, allow the agent 1 and agent 2 to be ready for extinguish, squib and squib. Okay, so only after finish isolation, you release the agent push button as extinguish procedure to extinguish the fire. So remember always for engine fire procedure, isolations and fire extinguish, everybody. Okay, so as you can see here, everybody, the dual sensing element loops are monitored by a fire detection unit, FDU, like in the Airbus A300, A310, A320 family, A330, A340, and A380 aircraft. The fire protection function based or hosted in SBIOM in the A350 aircraft, or the fire detection and extinguish control unit in the A220 aircraft. This is other name for the fire detection unit. In the A350 aircraft, and in the A220 aircraft. Okay, everybody? Okay, so reliability of the engine fire detection system. The design and redundancy of the detection loops ensure a high level of reliability for the engine fire detection system. In the event of an engine fire alert, the flight crew must rely on it. Again, in the event of an engine fire alert, the flight crew must rely on it. So whenever you have engine fire indication in the cockpit, don't delay the procedure, everybody. Don't delay the procedure and rely so much on the engine fire alert, and whenever you have the alert, do the procedure as fast as you can. Immediately, don't delay the procedure. Okay, everybody, don't delay the procedure. Otherwise, the fire situation may become worse. Okay, everybody, fire situation may become worse. Okay, so this schematic is for the engine fire detection system on an A320 aircraft with CFM engine. The blue line is the fire detection loop A, and the red line is the fire detection loop B. Okay, everybody? Okay. And also, everybody, you need to take care. Even if the engine may suffer from an engine fire, the engine parameter, may still be stable. Okay, everybody? Engine parameter may remain normal during an engine fire. You need to take care. Engine parameters may remain normal during an engine fire. And this is the mistake that many pilots go with. They do have an engine fire indication, and they have a normal engine parameter. So they delay the procedure. They think maybe the engine fire indication is not accurate. So they delay the procedure and the situation become more worse. Okay, everybody? So as you can see here, flight crew must be aware that engine thrust and engine parameter can remain normal in the early stage of an engine fire. And the event described in this article illustrates of this fact. In part 1 of this video session, okay, I describe an incident that the pilot delays the procedure, so they have a very bad scenario. Delays the procedure of engine fire, so they suffer from a very bad scenario. So as a key point from this article, in the event of an engine fire alert, the flight crew must apply the procedure even if the engine thrust is stable and the engine parameter are normal on the engine display and on the engine system display page. You know that the engine parameter indication come up on the upper ECAM and lower ECAM. On the upper ECAM, we have the primary engine indication parameters, like EBAR, N1, N2, EGT, fuel flow. This is the primary engine parameters, main control parameters, main thrust indication parameters. And on the lower ECAM, everybody, we have the engine secondary parameter, like oil quantity, oil pressure, oil temperature, vibration indication, engine starting indication. Okay, everybody? So again, in the event of an engine fire alert, the flight crew must apply the procedure even if the engine thrust still stable and the engine parameter are normal. Okay? So don't do this as a mistake and delay your procedure because the thrust is good or because the engine parameters are good. Okay, everybody? Don't delay the procedure, everybody. Don't delay the procedure. So as you can see here, apply the engine fire procedure without delay. Apply the engine fire procedure without delay. So the architecture of the nacelle is designed to contain the fire threat for a minimum but also limited time. Therefore, the flight crew must apply the engine fire procedure without delay when there is an engine fire alert. Again, the flight crew must apply the engine fire procedure without delay when there is an engine fire alert. Timely application of the engine fire procedure will limit fire propagation and prevent further damage to component or pipe around the engine core. Such damage could cause additional leaks of flammable fluids, which could increase the intensity or duration of the fire. So if you delay your procedure, you may suffer a bad scenario, okay? And such bad scenario can take us to an additional leak of flammable fluids, which could increase the intensity of the fire or the duration of the fire, Okay, everybody? So here we have a best practice. The use of autopilot in the case of an engine fire alert reduce crew workload and enable a safe handling of thrust asymmetry that is induced when thrust is reduced on the affected engine. So it's good to have auto thrust engaged and active during engine fire situation, because you need to handle the thrust asymmetry situation thanks to the auto thrust in that case. Again, the use of the autopilot in the case of an engine fire alert reduce crew workload and enable a safe handling of thrust asymmetry that is induced when thrust is reduced on the affected engine. Therefore, the flight crew can apply the ECAM procedure earlier and under less stress. This is particularly useful in phases of flight with a high workload, such as initial climb and the approach phase. So again, everybody, as a best practice, it is good to have auto thrust engaged and active during handling of an engine fire procedure to handle correctly and accurately the thrust asymmetry situations that will be initiated due to engine fire on one engine, okay, in that case. Okay, everybody? Okay. So, detection, fault, and fire propagation. Detection, fault, and fire propagation. The event described in this article show how a fire can propagate and damage the fire protection loops. Due to the delay of engine fire procedure, the fire initiated allow both fire detector loops to be faulty. And this is a very bad scenario, which cause the engine fire warning to stop and be replaced by a fire detection amber fault. As a precaution, the flight crew should interpret a replacement of the engine X fire red alert by an engine X fire detection fault amber alert as the sign of propagating fire. So if you have an engine 1 fire, for example, and you delay the procedure, so the fire intensify and the fire broke or allows the two detection loops to be faulty. So the engine fire indication go out and replaced by an engine fire detection fault. So if you have such a scenario, so don't go into like a confusing situation and say that the fire is went or the fire is done. No. In that case, the fire intensify and broke down both loops for fire detection. So when both loops go faulty, the engine red fire indication go out and replaced by an engine fire detection fault. So whenever you have such a scenario, everybody, it is a sign of a propagating fire, not an extinguish fire. It is a sign of a propagating fire, not an extinguish fire. So don't be happy in such situation, everybody. Okay? So engine X fire can similarly be replaced by both loop engine X loop A fault and loop engine X loop B fault on A300-600 and A310 aircraft. And on A220 aircraft, left engine fire detection fail or right engine fire detection fail can replace the left engine fire or right engine fire alert. Okay, everybody? So again, this is a very good best practice and a very good summary. If you have an engine fire red ECAM alert and you delay the procedure so that the fire propagate and broke down both loops, so now the red engine fire ECAM alert will go out and replaced by detection fault, engine fire detection fault. In that case, it is a great sign or a big sign of a propagating fire, not an extinguished fire. The scenario become more worse, not solved everybody, not solved everybody. Okay? So as you can see here, everybody, these are the steps of the engine fire procedure. And remember, for engine fire procedure, nacelle fire, external fire, remember isolation and fire extinguish. Isolations and fire extinguish. Engine shutdown, engine isolation, fire extinguish. Okay, everybody? So the first step of the engine fire procedure is to set the thrust lever to the affected engine to idle. This to decrease the ventilation of the nacelle. Decrease the ventilation of the nacelle, because when you deploy the agent halon gas, it will be effective. And set its master switch to off. Isolate the fuel. This will cut the fuel supply to the affected engine by closing the high pressure and low pressure fuel valve. Master lever off, close high pressure fuel valve on the wing and low pressure fuel valve on the engine. High pressure fuel valve on the wing and low pressure fuel valve on the engine, so that the engine will be immediately shut down or cut down. Okay, everybody? Okay. Engine isolation, release the fire push button. The second step is to press the engine fire push button for the affected engine in order to completely isolate the engine from the fuel. Releasing the fire push button confirms the closure of the low pressure fuel valve. IDJ de-energize, hydraulic cut off, pneumatic system cut off. Is to prevent further damage or fire propagation and prevent smoke from entering the air conditioning system. So if you delay the engine fire procedure, smoke may be go through the air conditioning engine system to the cabin. In that case, the passenger will smell smoke and the cabin will full of smoke and the situation become more worse. When you finish engine isolation, shutdown isolation, then you can release the fire bottles, fire extinguish. The third step is to extinguish the fire by discharging the fire agent, agent 1 and agent 2, into the nacelle, one after the other when in flight or simultaneously when on ground. On A220 on the ground, the procedure also requests to discharge the agent one after the other. The 10-second delay requested by ECAM procedure to discharge agent 1 in flight enable N1 to decrease. This will reduce ventilation of the nacelle so that the fire extinguish agent is more effective. Okay, everybody? Okay. So as a key point, everybody, the flight crew must complete all the steps of the procedure and discharge the agent as long as the engine fire alert is displayed and the fire lights are still on the overhead panel and pedestal. So how you can confirm that the fire is extinguished? Maybe you release agent 1 in flight and you can see that the red light on the fire push button went out, the fire indication underneath the master lever go out, and the engine fire procedure on the ECAM go out. This is an indication that the fire extinguished and you are now satisfied. And don't release the second agent in that case. Okay, everybody? Okay. So as a summary, everybody, to part 1, part 2, part 3 of this article, you need to understand that aircraft engines are equipped with a reliable fire detection system, dual loops. Flight crew must be aware that in the event of an engine fire alert, the engine parameters can remain normal in the early stage of the fire. Therefore, the flight crew must apply the ECAM or ICAS procedure without delay, even if the engine display and engine system display page display normal or nominal parameter. So if you have an engine fire alert, red ECAM alert, or red ICAS alert, and you can still having stable thrust or stable parameter of the engine, don't confuse, don't delay the procedure, do the procedure as fast as you can. As timely application of the engine fire procedure, limit propagation of the fire and prevent further damage to component or pipe around the engine core that may create additional leaks of flammable fluids and increase the intensity of or duration of the fire. If you delay the procedure, the intensity of the fire may be propagate, and the duration of the fire may be higher. So the flight crew, everybody must complete all the steps of the engine fire procedure and discharge the agent as long as the engine fire alert is displayed and the fire lights are still on the overhead panel and the pedestal. If the light of fire indication is still on, fire is still on. If the light on the fire push button or underneath the master lever go out, fire is extinguished. So by taking decisive action when there is an engine fire alert, the flight crew can prevent a manageable fire situation from becoming an uncontrolled fire with more serious consequence. Okay, everybody. Thank you always for your good listening, and always fly safely and maintain your aircraft very safely. This was part 3 from our series, Don't Delay the Engine Fire Procedure. Don't delay the engine fire procedure. Please see part 1 and part 2 for more clarification, and always understand that this is not a formal training, it is a performance-based training. It is an added value to my fellow pilots and my fellow aircraft maintenance personnel. From Cairo, Egypt, your host was Haitham Ali, and I'm an aviation technical instructor. Please stay tuned for an upcoming sessions like this to increase your awareness regarding aircraft systems. Thank you always and goodbye.